Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science and Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about chi-square and then t-tests. So the very basic important terms that would like to remember is that parametric test and the non-parametric test and what should be the hypothesis. So parametric test is nothing but this is the test in which the population constants like mean, deviation, standard error, correlation, coefficient, proportion, etc. and data tend to be follow the assumed or established distribution such as nominal, binomial, and Poisson, etc. So non-parametric test means this is the test in which the no constant of population is going to be used and data do not follow any specific distribution and no assumptions are going to be made in this test. And in order to classify this, have to be good, better, and best in such a way that you have to allocate arbitrary numbers or marks to each category. Hypothesis is nothing but this is it is a definite statement about the population parameter. So the basic terms that we should be remember parametric test. So what is the parametric test? So this is the test in which the population constants like mean, standard deviation, and then standard error, correlation coefficient, proportion, etc. Okay, and the data tend to follow one of the assumed or established distributions such as nominal and then binomial and then Poisson distribution. A non-parametric test means this is the test in which no constant of population is going to be used and data do not follow any specific distribution or no assumptions are going to be made in this test. And for example, in order to classify this good, better, best, we just allocate the arbitrary numbers or we can able to do marks to each category. And hypothesis. So what should be the hypothesis here? So hypothesis is nothing but the definite statement about the population parameter. And next one is null hypothesis, and what is the alternative hypothesis? We'll see now. So in null hypothesis, it is going to be state that no association exists between two cross tabulated variables in the population, and therefore the variables are going to be statistically independent. For example, if you want to compare the two methods, method A and method B for its superiority, and if the assumption is both the methods are equally good, and this assumption is called null hypothesis. So null hypothesis states that there should not be any association exists between the two cross tabulated variables in the population, and these variables are going to be statistically independent. So suppose if I want to compare the two methods A and B like this for its superiority, so the assumption is to be done on both methods that should be equally good, but this assumption is going to be called as a null hypothesis. What is this alternative hypothesis? Is that so? This one should be represented as H naught, whereas null hypothesis is going to be represented through H naught, and alternative hypothesis is going to be represented through H1. So this alternative hypothesis proposes that two variables are related to the population. So if I'm going to assume that from two methods, so the method A is superior than the method B, and this assumption is called alternative hypothesis. So that means so the proposes two variables are going to be related in the population. So if I want to assume that from two methods, then method A is superior than method B, then assumption is called alternative hypothesis. And next one is that degrees of freedom. And what is contingency table? So the degree of freedom is nothing but if we want to denote the extent of independently enjoyed by the given set of observed frequencies, then we're going to given a set of unobserved frequencies which are going to be subjected to k independent constraints. And for the degrees of freedom can be defined by the equation the number of frequencies by this number of independent constraints on them. So in other terms, I can able to define as degrees of freedom is equal to r minus 1 into c minus 1, where n should be the number of rows and c should be the number of columns. So it denotes that extent of independency enjoyed by the given set of observed frequencies. Suppose if we are going to give a set of unobserved frequencies which are going to be subject k independent restrictions, then uh, I can able to say that the degrees of freedom equal to number of frequencies minus number of independent constraints on them, where r minus 1 should be the number of rows and c minus 1 should be the number of columns. Contingency table means, so when the table is going to be prepared by the enumeration of quality data by entering the actual frequency, and if the table represents the occurrence of two set of events, then the table is called contingency table. So it is also called as association table. So when the table is going to be prepared by enumeration of qualitative data, so by entering the actual frequencies, and if the table represents the occurrence of two set of events, then it is called contingency table. Then we are going to see about, once you know all these terms, we can able to see what is the chi-square test and then t-test. So chi-square test is an important test among the several tests of significance developed by the statisticians, and it was developed by Kurt Person in 1900. So chi-square test is a non-parametric test based on any assumption or a distribution of any variable, and this statistical test follows the specific distribution known as chi-square distribution. And in general, the test what we can able to measure the difference between what is going to be observed and what is going to be expected according to the hypothesis is called a chi-square test. So chi-square test is an important test among the several tests of significance, so mainly used by the statisticians. And it was involved by Pearson in 1900 itself, and it should be a non-parametric test, so not based on any kind of assumption or distribution of the variable. And so the statistic test follows the specific distribution such as chi-square distribution. So in general, the test what we can able to measure is the differences between what are going to be observed and what we are going to be expected, the difference between them according to the assumed hypothesis. So that thing should be treated as a chi-square test. So, what are the important characteristics of chi-square test? So, this test is based on the frequencies and not on the parameters like mean and standard deviation. And these tests are going to be used for testing the hypothesis and not useful for the estimation mainly. And this test can be applied to the complex contingency table, so with several classes, and such is very useful test in research work. And this test is an important non-parametric test as no rigid assumptions are necessary in the regard to type of population and no need of parameter value. So relatively less mathematical details are going to be involved. So chi-square test mainly called as a non-parametric test, and it should be based on frequencies, not on the parameters like mean and standard deviation. And this test is mainly used for testing the hypothesis and not for the useful for estimation. And this test can be applied to complex contingency table with several classes, and such a way it should be very useful in research work. This test is an important non-parametric test as no rigid assumptions are necessary and no need of parameter values, and relatively less mathematical details are going to be involved. Chi-square test. So if x1, so x2, and so on are independent normal variables, and each is distributed normally with mean 0 and standard deviation unity, then at the x1 square plus x2 squares 1 xn square should be distributed as I square with n degrees of freedom, with where n should be the large, and the chi-square curve for the definite values of n equal to 1 to 9 is as follows. So suppose if I'm going to take some values x1, x2, and so on, xn up to xn values, I'm going to take with normal uh, with in an independent normal variables, and each one is going to be distributed normally with mean value 0 and the standard deviation should be 1. Then the equation is going to be given by x1 square plus x2 square plus x3 square and so on xn. So that should be written as xi square. That should be distributed as I square with n degrees of freedom. So where n should be the large and where the curves are going to obtain by 1, 5 and then 9. Suppose if the degrees of freedom is greater than 2, then the distribution is bell shaped, and if the degrees of freedom equal to 2, then it should be L shaped with maximum alternate at 0, and if the degrees of freedom is less than 0, then the distribution L shaped with an infinite alternate at the origin. So these are the three kinds of options we are going to have based on the degrees of freedom. So if the degrees of freedom should be greater than 2, then the distribution should be bell shaped, and if it is equal to 2, then it should be L shaped, and if it is less than 2, and then it should be an L shape with infinite originate at the origin. So what is the application of chi-square test? So this test can be used in the goodness of fit of distributions, and the test of independence of attributes and test of homogeneity. So this test mainly used in the goodness of the fitness of the distribution, and also be used in test of independence of attributes and test of homogeneity. So next one, the test of goodness of fit of distributions. So mainly this one, this test enables us to see how well does the assumed theoretical distribution such as binomial, nominal, and ordinal distribution going to fit with the observed data. And chi-square test formula is going to be given by fitness. Good fitness is given by, so x square is equal to sigma omni observed minus estimated value whole square by estimated value. So what we can able to call it as observed frequency by where E should be the expected frequency. So suppose if the chi-square calculator is greater than the chi-square tabulated, then within n minus 1 difference, the null hypothesis is going to be rejected, otherwise it should be accepted. Whenever if the null hypothesis is accepted, then it is concluded that the given distribution follows the theoretical distribution, right? So the test of goodness of fit of distribution. So this test enable to see how well does an assumed theoretical distribution such as binomial distribution, Poisson distribution, normal distribution is going to fit the observed data. And chi-square test formula for the goodness of fit should be given by, so x square is equal to sigma omega e whole square by s e, where O should be the observed frequency and E should be the expected frequency. If the chi-square calculated is greater than the chi-square tabulated with n minus 1 difference, the null hypothesis is going to be rejected, otherwise it should be accepted. If the null hypothesis is accepted, then it should be concluded that the given distribution should be theoretical distribution. And next one is that the test of independence of attributes. So normally, in case of independence of attributes, so this test unable to explain whether or not two attributes are going to be associated. So, for instance, it may be separate, it may be interested in knowing whether the new medicine is effective in controlling the fever or not. So, the size square test should be useful. Suppose, for instance, like so whether I have to know whether the new medicine is should be an effective in controlling the fever or not. So, for that, I have to conduct the size square test. So in such a situation, we must proceed with the null hypothesis that two attributes, so new medicine and control of fever, are the two independent one, which means that the new medicine is not effective in controlling the fever, is the null hypothesis. So then the chi-square calculated it should be greater than the chi-square tabulated at the second level of significant of given degrees of freedom, then null hypothesis is going to be rejected. That means the two variables are said to be dependent. And suppose if the chi-square calculated is less than the chi-square tabulated, the null hypothesis is going to be accepted. That means the two variables are independent one, the new medicine is not effective in controlling the fever. So whenever the null hypothesis is rejected, then it should be concluded that there should be a significant association between the two attributes. So these are some of the instances that may occur in the testing of independence of variable for the chi-square test. So normally the chi-square calculated value and the chi-square tabulated value should be there. So whenever it should be greater than this, then it should be, then H naught should be rejected. So whenever the value is less than this, then it should be H naught is going to be accepted. So that is the significance of test of two attributes. Next one is test of homogeneity. So this test can be used to test whether the occurrence of events follow the uniformity or not. Example: the admission of patients in government hospital in all the days of week is uniform or not can be tested with the help of chi-square test. So this test can be used to test whether the occurrence of events follow the uniformity or not. Example: the admission of patients in government hospital in all the days of the week is uniform or not can be tested with the help of chi-square test. Whenever the chi-square calculated value is less than the chi-square tabulated, then the null hypothesis is going to be accepted. That means it can be concluded that there is a uniformity in the occurrence of events. So test of homogeneity means that this test is going to be used whenever the occurrence of events follows the uniformity or not. For example, the admission of patients in government hospital in all the days is uniform. Suppose in Monday, the number of patients admitted is 50. In Tuesday, it should be 50. Wednesday, it should be 50, like this. So I have to check the uniformity of the patients whether in all the days it should be same or not. So in this case, I can able to perform chi-square test. So what is the equation for chi-square test? So just now I said, so z square is equal to sigma O minus C whole square by E. So where O should be the observed frequency, E should be the estimated frequency or expected frequency. If the two distributions are exactly like psi square equal to 0, then psi square is not equal to 0. So based on this equation only we can able to calculate the psi square value. So it should be sigma O minus C, that should be observed minus frequency minus estimate frequency by estimation, then I can able to get the psi square value. So what are the steps involved in calculating the psi square? So normal first you have to calculate the expected frequency and observed frequency. So expected frequency means the self frequency should be would be expected in contingency table, and the two variables were statistically independent. And observed frequency means the self frequency is actually observed in contingency table. So that should be given by the column total by row total. So here we have to calculate the estimated and observed frequency. So estimated frequency means that the self frequencies would be expected in the contingency table. The two variables were statistically independent. And the observed frequencies means the self frequencies actually observed in contingency table. So the chi-square test should be calculated as follows. So sigma f of e minus f of o whole square by f of e. So expected frequency f of e should be f of o should be observed frequency. So what are the limitations of this chi-square test? So the very first thing is that the data is from the random sample only, and this test can be applied in four table, which should not be reliable a result with 1 degree of freedom. And if the expected value in any cell is less than 5, then such that you have to calculate the 8 correction is necessary. So even if the 8 correction is necessary, then the test may be misleading if any of the expected frequencies that should be below 5. In the contingency table, we should be larger than 2 by 2, then 8 coefficient cannot be applied. And we have to interpret this test caution if a sample total or sample values in all the cells should be less than. Okay, so some of the limitations of this I-square test will be, so the data is from random sample, and this test is going to be applied in fourfold and will not be reliable to the result with 1 degree of freedom, and if the expected value in the cell is less than 5. And even if the 8th coefficient, so the test may be misleading if any unexpected frequency is much below 5. And in the contingency tables, so larger than 2.2, and we have to be interpret this test precaution if the sample total or the total values should be less than 50. And this test tells the presence and occurrence absence of association between the events, so but does not measure the strength of association. And this test does not indicate the cause and effect, so it only tells the probability of occurrence of association by chance. And this test is only applied whenever the individual observations of sample are going to be independent. So, which means that the occurrence of one individual observation may not affect on the occurrence of other observation. So, this test mainly tells the presence and absence of association between the events and does not measure the strength of association. And this test does not indicate the cause and effect, so it only tells the probability of occurrence of association by chance. And next one is the t-test. So what does the t-test means? So that should be the distribution and evaluation for the group distribution. And so we have to be withdrawn from normal distribution. And the shape of the distribution depend on the sample size, and sum of all the distribution is a normal distribution. And t-distribution is based upon the sample size and vary according to degrees of freedom. So the t-distribution mainly means about the distribution and then evaluation for the group distribution. So normally this one is going to be withdrawn from the normal distribution, and the shape of this distribution depending on the sample size and then sum of all the distribution in the normal distribution. So t-distribution is based on sample size and should vary according to degrees of freedom. So what is t-test? So t-test is a very useful technique for comparing the mean values of two set of numbers. And this comparison is going to be provide you a statistic for evaluating whether the difference between the two means is statistically significant or not. And the t-test can be used either it have to be compared the two independent groups, and you can able to compare the observation from two or more measurement occasions for the same group. So you have to be compared two independent groups, and you have to be compared observation from the two measurement occasions from the same group. So that should be paired samples and t-test. So in the null hypothesis states that if there is any two different significant difference between the two means, so that should be result to different distribution. So remember that the both samples are going to be drawn from the same population, and comparing that the chance of having difference in one group due to the difference in distribution. So assuming that the both distribution came from the same population, but both distribution has not been equal. So in t-test, so the null hypothesis states that should not be any difference between the two means, and remember that the two samples are going to be drawn randomly from the same population, and comparing the chance of difference in one group due to the difference in distribution. So in order to find the difference between the due to chance, so logically the larger the difference in means, that more likely to find the significant test. So variability, so more less variability is equal to less overlap and larger difference. And sample size, so larger sample size means large variability, so that should be equal to the large difference. So what are the different types of t-tests here? So one sample test, independent sample test, and paired sample test. One sample test is used to compare a single sample with the population value. For example, a test could be conducted to compare the average salary of nurse within a company with a value that was not known to represent the national average for nurses. An independent sample test is used to compare two group scores on the same variable. For example, it can be used to compare the salaries of nurses and physicians to evaluate whether there is a difference in their salaries or not. And paired sample test means it is used to compare the means of two variables within a single group. For example, I could be used if there is a significant difference between the starting salaries and the current salaries among the general nurses in the organization. So these are the different types of sampling tests. So one sampling test means which is going to be compared only in the single sample within a population. For example, if the test could be conducted to compare the average salary of a nurse within a company, then should be treated as one sample test. So independent sample test means which is going to be compared two independent group scores on the same variable. Suppose if you want to compare the salaries of nurses and physicians to evaluate whether there is a difference in the salary or not. And paired sample test means which is going to be compared means of two variable. For example, it could be compared to see if there is a statistically significant difference between the standard salaries and current salaries among the general nurses in an organization. So, what are the assumptions have to be made of the t-test? So, the dependent variables are interval or maybe a ratio scale, and the population from which the samples are going to be drawn that should be normally distributed, and samples are going to be drawn, randomly selected, and the groups have equal variance, what we call as homogeneity of variance, and the t-tag statistic is robust, so it should be reasonably reliable even if the assumptions are not fully met. So the basic assumptions is that so the dependent variables are interval or ratio scaled, and the population from which the samples are drawn is normally distributed only, and these samples are randomly selected, and the groups have the variance that should be homogeneity of variance, and t statistic is the robust one, and it should be reasonably reliable if the assumptions are not fully met. So some more assumptions that so it should be continuous one, and the group should have randomly selected drawn from the normal distributed and independent populations like male, female, nurse, physician, manager, and staff. So there should not be any overlap. So that's why it should be continuous one, and the group should be randomly drawn from the normally distributed and independent population. So the independent variable is a categorical with the two levels, and the distribution for the two independent variables should be normal one, and equal variance, so that should be homogeneity of variance. So the larger variance is equal less likely to have t-test accepting null hypothesis, and or it may be failure to reject, and type 2 error means a threat of call. So some other assumptions is that so independent variable is categorical with the two levels here, and the distribution of these two independent variables should be normal only, and equal variance, so it should be homogeneity of variance, and the larger variance means like less likely to have significant t-test, and that should be equal to almost all null hypothesis, that should be the reject or fail, and type 2 errors that should be threat to power is going to be obtained. An independent sample test is used when we are going to have two independent samples that should be the treatment or controlling groups, and the formula is going to be divided by this. So x1 bar minus x2 bar by sc bar. So in the denominator is the standard error difference between the means, and the terms in the numerator are the sampling means. So next one is dependent sample t-test. So this is going to be used whenever we're going to have dependent samples matched, paired and tied. So like repeated measures, whether sister, husband and wife, left hand, right hand, etc. like this. and this one is going to be used to control the individual differences and can able to result in more powerful test than the independent sample test. So mainly this dependent sample test is going to be used when we are going to have the dependent sample matched, and mainly this one is going to be used to control the individual differences and then can able to result in more powerful test than the individual sample test. And this dependent sample test is going to be given by the equation. So T of xt bar is equal to d bar by sc difference, where T is the difference in means over standard error. So if that standard error difference is going to be given by st bar by square root of n pairs, and the standard error is going to be obtained or found by finding the difference between the pair of observations, and the standard observation of this difference is SD, and this one is going to be get the standard error difference. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.